Bismillahirrahmanirrahim. Assalamu alaikum students. Warm welcome to all of you to the third lecture of physics from Unit 2 Kinematics. The topic which I am going to teach you is the scalars and vectors. Students, you are familiar with the term physical quantities. You have read about the physical quantities in Unit 1 in class 8. Here I briefly define the physical quantities. Quantities that can be measured with the help of the measuring instruments are called physical quantities. For example, length. Length can be measured with the help of the meter ruler. Mass can be measured with the help of the physical balance. Volume of a liquid can easily be measured with the help of the measuring cylinder, and time is measured with the help of a clock. So length, mass, volume and time all are the physical quantities. On the basis of direction, physical quantities are divided into two main types, scalars and vectors. Students, first I explain concept of scalars to you with the help of some examples. Suppose you go to the shop and say to the shopkeeper that you need 5 sugar. When the shopkeeper hears the word 5 sugar, he gets confused. He is unable to understand what you really want. He thinks that you may need either 5 packets of sugar or 5 kilogram of sugar or 5 gram of sugar. But if you say that you need 5 kilogram of sugar, he can easily fulfill your demand. So, only the number is ambiguous. Along with number, unit is necessary to explain what you actually want to say. So, number together with its proper unit is called magnitude. All quantities need magnitude for their description. For example, if my friend asks from me that how much time did I take to reach her home, I reply that I took 30 minutes north, to reach her home. But when she hears the direction north with time, she is confused. If I say that I took only 30 minutes to reach her home, she can easily understand what I am saying to her. It means that the direction with time is irrelevant. Another example is if someone suffers from fever and I ask from her that what is the temperature of your body, she says 102 degree Fahrenheit. I can easily understand what she is saying because magnitude explains the physical quantity. Here number and its unit explain the temperature of her body. The quantities that needs magnitude, not the direction for their description, are called scalars. For example, my father brings 5 kilograms of mangoes to home, and we already have 3 kilograms of mango. So, how many mangoes do we have? We have 8 kilograms of mango at home. For example, if I have 10 meter of cloth and my sister needs 3 meter of cloth for her shirt. I gave her 3 meter cloth out of 10 meter cloth to her. How much cloth is left with me? It is 7 meter. My father buys a piece of land whose length is 600 meter and breadth is 20 meter. So the area of land which my father has bought is 12,000 meter square. From these examples you see that here I use only magnitudes: 5 kilogram, 10 meter, 600 meter, 8 kilogram, 7. So mass, length and area all are explained only with their magnitudes. So area, length, mass, time, temperature all are scalar quantities that need only magnitude for their description. You also notice that magnitudes or scalar quantities can be added, subtracted and multiplied by using ordinary mathematical rules. From this discussion, we conclude that scalar quantities can completely be described by their magnitude only. They do not need direction. These quantities can be added, subtracted and multiplied by using ordinary mathematical rules. Few examples of scalar quantities are length, mass, time, volume and temperature. Now, I explain concept of vector to you with the help of an example. For example, if you are invited to your friend's house, she told you that her house is 2 meters away from Gulbahar Chowk. When you reach at the Gulbahar Chowk, you see 4 routes. You know that her house is 2 meters away from Gulbahar Chowk, but you do not know in which direction you have to move to reach her home. Here she only gives you the magnitude 2 meter and this magnitude is called distance. It means that her home is 2 meter at a distance of 2 meter from Gulbahar Chowk. Here only magnitude is given, so distance is a scalar quantity. But she tells you that her home is at a distance of 2 meter east. So you can easily reach her home because here direction helps you. So when we add direction to the magnitude, now it is no more a distance. Now it is called displacement. And displacement is a vector quantity. Those quantities that needs magnitude as well as direction for their description, such quantities are called vector quantities or simply vectors. From the above discussion, we conclude that vector quantities can completely be described by their magnitude as well as direction. Vectors must need direction. Vectors cannot be added, subtracted and multiplied by using ordinary mathematical rules. We need special rules for the addition, subtraction and multiplication of vectors. For example, head to tail rule. Students, head to tail rule is not the part of this lecture. Inshallah, we will study head to tail rule in chapter 4. Now I'm giving you a few examples of vector quantities. First is the weight. Students, you have observed that if you throw something upward, it always comes to the ground. Or if you release any object from a height, it always moves towards the earth. The object moves towards the earth due to its weight. So it means that weight is a vector quantity because it has direction along with the magnitude. And direction of weight is downward. Now I am giving you another example of vector. Force. Force is a vector quantity. Suppose the engine of the car produces applied force. Applied force is the force that tends to move the car. So when the car starts moving, this black arrow shows the direction of motion. Direction of motion here means the direction in which the car is traveling. Applied force starts the motion of the car, so direction of the applied force is here shown by the blue arrow. So the direction of applied force and direction of motion is the same. Now, if we apply the brakes, the tire of the car rubs with the road. As a result of this rubbing, friction is produced. And friction is the force that tends to stop the motion of the car. So the direction of friction is always opposite to the direction of motion of car. Why? Because here this is the applied force. It starts the motion, and friction is the force that stops the motion. The function of these two forces are opposite, so their direction is also opposite. So whenever we talk about the force, we must mention direction along with its magnitude. So it is a vector quantity. Along with weight and force, velocity and acceleration are the other few examples of vector. I am not explaining velocity and acceleration to you here because we will explain this topic in the upcoming lecture. Thank you, girls. Thank you very much.